Okay, welcome back. We're going to look at solving some systems algebraically. Last time we talked about how to do it graphically using our calculators, and we saw that we could graph two different lines, two different curves, two different parabolas, whatever the case was, figure out where those lines intersected, and we could find our solutions. Now, we're going to do the same thing we talked about last time, but algebraically, and look at a couple of those methods. Now, it's going to look very familiar if you remember systems of equation from Math 10C, when we looked at doing elimination and substitution. Those two methods will come back here as well. We've just got something that looks a little bit more complicated. So we'll start out by looking at this linear quadratic system. So we've got one of those equations being quadratic, that's our x squared parabola. The other one is the line x plus 2 that has a slope of 1, a coefficient of x, and a y-intercept of 2. So if you imagine this, you're going to have your parabolic shape and a line that goes through it, and it might have two solutions depending on where it goes through. So if we take a look at this, we can see that these y's are actually the same because a system is built on common variables. So the y in one should be the same y in the other one. And we can use that to our advantage because if y is equal to two different things, those two things should be equal to each other. So we could say here that x squared is equal to x plus 2 by using that idea. So by taking those two equations and making number 1 equal to number 2, since they're equal to the same thing, we can now have something we can deal with. Now, if you think back to quadratics, you had something that was squared that now we have to solve this. So we're going to make it equal to 0, and then our goal is to factor it if possible. So that means x squared minus x minus 2 is going to be equal to 0. So we're really looking for the two factors that make this possible. So if we go to factor, we can use our sum and product rule that you've learned before, and we could say that the two numbers that I need to multiply to -2 but add to -1, I could use a -2 and I could use a +1. So x plus 1 will be my other factor. This means that I could have two potential answers here. If I choose x to be +2, that would zero out this left side according to the zero product property. So as long as one of these factors is equal to 0, the whole thing is equal to 0. Now there's two places where that happens. X is either +2 or x is either -1. So I'll show you what I mean in this next step here. So what you're going to do is take each of those factors, make them equal to 0 to find the specific spot where that happens. So if x is 2, that one is 0. X plus 1 equals 0. If x is equal to -1, there's your other answer for x. Now remember what the solution to a system really is. It's an intersection point. Now we only have the x coordinates. We need to find the y coordinates as well. So what we can do is, just like before, take one of those x values, substitute into one of our equations to get a y value. Now you could pick either one. Pick the simpler one here. So if we just square those x values, we're going to get our y. So let's do that on the other side. So if x is equal to, I believe that was 2 for one of them, then that means it's y equals to 2 squared, y is equal to 4. So one of our points is going to be 2, 4. There's one of the intersection points. If x is equal to, I think that was -1. Yeah, -1. Then this means if we do the y squared equation again, that means y is equal to 1. So our other intersection point is going to be 1, 1. So these should be our two intersection points, the two answers that solve this system, the only two. And we'll check it in our calculator as well, just to give you a refresher of last time. So we'll do our x squared in one of those equations. In y2, we'll put in the x plus 2. We'll hit graph. And there's our parabola like we talked about, and there's our line going through it. So you can clearly see there's two different intersection points. Now we're going to go try to figure out what they are on here. So second trace brings up our menu for calculate. Option 5 is intersect, so you can press it. Move your cursor close to one of the intersection points, then hit enter 3 times. And basically your calculator is going to cycle through the two equations, and taking that information, it'll figure out where it is that they intersect. Okay, so negative 1, 1. I forgot to put the negative attached to my point, so there we go. This is why we double check things. So now my x coordinate matches what I said it did in the beginning. I just forgot to write it, but it is negative 1, comma 1. There's one of our points. We'll check the other one as well, so we have to go through that whole calculate process again, intersect. Move the cursor this time closer to the other intersection point. Doesn't have to be exactly on it, but then if you do that, enter 3 times business, you can see that the other intersection is 2, 4, just like our algebraic method said it would be. Now, if we needed to show our verification step here, what we would actually have to do is take those x and y points, substitute them into both equations. We need to make sure they work for both to show that the left side equals the right side. So we're going to do that verification step on this one, but I'm not going to do the verification for the other ones. Okay, just to save us a bit of time in this video. So I'll show you how to verify it. If you are asked to verify it, please make sure you do it. But if you aren't asked, then I guess you're not asked, so don't worry about it. It is a good practice to get into, not only checking it either algebraically or on your calculator. That way you know for sure you got your answer right, because you can even see that I forgot the negative when I wrote it, then that could lead to some errors down the way. So let's do that verification by hand as well. So there's our verification. So one of our equations was y equals x squared. So we need to check both points. So we're going to put in the first one, 2, 4. So 4 was y. X is 2, 4 equals 4. That checks out. That's good. Check the other one as well. Y equals x squared. 1 should be equal to negative 1 squared. 1 is equal to 1. That one's good. Okay, we've got to check the other equation as well. So leave a little bit of space. So y equals x plus 2. So 4 should be equal to 2 plus 2. And again, you can see that 4 equals 4. That one's good. Other equation, or other point, I should say, x plus 2. 1 should be equal to negative 1 plus 1. 1 is equal to 1. Okay, so both points check out in both equations. So I know for with 100% certainty this is the correct answer. These are the 2 correct intersection points. And you saw that on your calculator as well. So as long as you know how to do that verification step, it's the same as Math 10C was. You just have 2 points to check. Okay. When you have 2 expressions equal to the same thing, the expressions themselves must be equal. So the same idea illustrated just using pictures. So in this, you can see that 2 circles are the same thing as 1 heart. But if I have a heart on the other side of the other scale, then that means that 2 circles should be equal to that heart. So 2 circles is actually also equal to 3 stars. That's a terrible start. There you go. Okay, so those 2 circles are equal to those 3 stars. So that idea is going to help you. Essentially, you just get rid of the y's by making everything else equal to it. You could do the same thing down here as well. Now, we basically did this in Math 10C. We called it substitution. Same idea. You can do that here also. So we'll do substitution for this one. We'll do maybe elimination for some of the other ones to show you both. So one of these equations already solved for y. So that's good. We won't touch this one. We're going to go to the other one and isolate for y. That way we can substitute it into the first one. So if we try to do that, let's move the x over. So let's minus x from both. So negative 2y is equal to negative x minus 15. Then we'll divide everything by negative 2. So that means y equals 1/2 x plus 15 over 2. So there's an expression for y. Now it's not nice because of the fractions, but that's okay. It's just unavoidable here. So we'll take that box that's blue. It's also equal to y. The other equation we didn't touch is also equal to y, so we can make the right sides equal to each other. So let's change colors. We'll say negative 2x squared plus 10 equals 1/2 x plus 15 over 2. Now the fractions again make this not nice, so let's take the whole thing and multiply it by 2 to get rid of the fractions. Okay, so this 2 would apply to everything inside the set of brackets, all 4 terms. So we're going to have a negative 4x squared plus 20 equals to x plus 15. Okay, much nicer to look at. So again, it's just a quadratic equation now that we have to solve. So move everything to one side, make it equal to 0, then try to factor it. So our x squared term is negative. It's easier to factor if it's positive, so we'll move it over. So plus 4x squared to both sides. And then we'll bring the 20 as well. So 0 equals to 4x squared plus x. It should be minus 5, I believe. Okay, now we've got to factor this. So we have a coefficient in front of that x squared, so we have to remember when we do our sum and product, we have to account for that as well. So we're going to try to multiply it to negative 20, add to 1. Now that product is coming from taking that first coefficient, the constant, multiplying them together, and that's why we're going to multiply to negative 20. The 1 is our middle term. The two numbers that'll do that are a negative 5 and a positive 4. So if we decompose that middle term, 0 equals 4x squared minus 5x plus 4x minus 5. Okay, and this is what we've got to factor now. It looks like we made it worse by introducing a fourth term, but this is going to be the only way we can factor this. So take the first two terms together, then the last two terms together. Now, just by looking at the last two terms, 4x and negative 5, there's no common factors between them. So I know I'm trying to get that from the first two terms. So essentially, these are going to be your groups, those first two items, last two items. And if you try to factor the first set of brackets, 0 is going to equal x, 4x minus 5, plus a 4x minus 5. So if your brackets are the same, you've got the same factor, you know you did it right. So one last step we have to take care of. So I got to move some stuff here. So move that over. This will come up there. So the last step we have to take care of, 0 is going to equal to basically our factored form of our factored expression. So 4x minus 5 is the common factor from those two terms. The coefficients, the x and the 1, become our other factor. So that'll be x plus 1. Now we can figure out what x is, and you can see we're going to have 2 again. So 4x minus 5 could be equal to 0, or x plus 1 could be equal to 0. So x is either 5 over 4, or x is equal to negative 1. So there's our factor, there's everything factored and done. So let's double check to make sure we did everything right so far. Subtracted 20, subtracted 20, that's a negative 5. My x there is positive. Ooh, I switched those two signs around. I knew something didn't look right. So let's fix this. I actually needed to add this to positive 1, which I did, but my numbers, when I add them, I actually get negative 1. So I've got to switch those signs around. So those numbers are going to swap. This is actually going to change to be 5 and negative 4. So switch that, switch that. Actually, this is going to be easier if I just do this. Yeah. Okay. So 0 equals 4x squared plus 5x minus 4x minus 5. That's better. Okay. So 0 equals, still take your x out of the first one, so you're still going to have that 4x plus 5. But when I get to this part with negative, I'm going to actually take out the negative sign as the factor. So a factor of negative 1, then introduce my bracket. So inside will become the same, the 4x plus 5. It doesn't look like I changed a whole lot, or fixed a whole lot, I should say. That negative sign is going to make our actual x values the reverse sign. So just take your time when you're doing this, because as you just saw, sometimes you miss a negative sign. So this will change to be 0 equals 4x plus 5 this time, and that will be x minus 1. So x could either be negative 5 over 4 or x could be 1. So there's my two numbers. Okay, we still have to figure out what y is actually equal to. So we're going to substitute them back into an equation. Now, it doesn't matter which equation you pick, so pick the one that's a little easier to work with. So we're going to pick the first one here. So we're going to say, I'll give myself a little room here. Let's use y equals negative 2x squared plus 10. And we're going to substitute in each of the points. So we'll do the easier point first. Let's make x equal to 1. So y equals negative 2, 1 squared plus 10. If I do that, that means y is going to be equal to 8. So now I can say that therefore, if x is 1, y is 8. There's 1 point. Now we've got to do the other one. So still find a little box there. So y equals negative 2, negative 5 over 4 squared plus 10. If I do that one, you can put the whole thing in your calculator as well. So we'll do, where did it go? There, right there. So negative 2 bracket, negative 5 divided by 4, close it, squared, and plus 10. And enter. You get a weird decimal, so let's change it to a fraction. You can do that by pressing math. So it's the button right under alpha. Number 1, we'll change it into a fraction if possible. So 55 over 8 is what we're going to use. So that the other intersection point could be negative 5 over 4, and then 55 over 8. Okay, so there's your two potential answers. One there, and one there. Okay, so as you can see, I made a little mistake too, but we caught it. And just be careful with the negatives because it doesn't really change a whole lot here. The only thing that basically was missed is that negative sign would basically be switched to the other point. We'll change your y's as well, but it might not be an error that you catch if you didn't do this verification. Okay, so we only caught it, well, because I had the answer key as well. But if I didn't catch it earlier and I tried to verify it, it wouldn't have worked. Okay, and we would have had to go back and redo it anyways. So just take your time to make sure that you do catch everything. I'm actually going to skip this one. If you do want to try it on your own, go ahead. You'll have the full solution in your notes in the key. The description will have it as well. So I'll give you the 2 points here if you do want to try it. So for example 2, that would be 1 negative 2 and 10/3 and 17 over 9. Okay, so those are going to be the 2 points for example 2. So again, like I said, you can try it out. You can look for the solution in your key or in the description box. It should have that in there as well. Okay, we'll do one of the ones on the back and we'll deal with that word problem also. So I did say we're going to talk about the other method, so elimination. And again, there's 2 here. I'm going to do the first one, and I'm going to leave this one as kind of a challenge. So we'll do this first one, and we're going to do it like we would do elimination. Now, personal preference here, I like to rearrange them first, the 2 equations, and follow the same format. So what I mean by that is our first equation goes x squared, x constant, but our second equation doesn't. So we're going to rearrange the second one to have the same format. So I'm going to say it's negative x squared minus 2x plus 1. And then we'll move the other one over, not changing a thing. So x squared plus 6x plus 9. There we go. Now, remember that they're both equal to y. Now, if both y's are the same sign, they're both positive, and you could do this with x as well, but doing it with y is easier. You could just take those 2 equations away from each other. So subtract if they have the same sign, and the result that you get will be equal to 0. Because we're going to do y minus y, that's going to give us 0. So now we're working on the right side of the equation. So x squared minus negative x squared, that's going to give us 2x squareds. 6x minus negative 2x, that's 8x. And then 9 minus 1, that is also 8. Okay, and I've got it in my quadratic form already that I need. It's already equal to 0. Elimination was pretty nice to use here. Now we've got to factor this. So let's take a common factor of 2 out first. So x squared plus 4x plus 4. Now you might recognize this trinomial as being a perfect trinomial because the two numbers that will multiply to 4 and add to 4 are 2 and 2. So that means when you factor this, you're going to end up with an x plus 2 factor twice. So x plus 2 squared, hence the perfect square trinomial part. So now we've got to figure out what the 0 actually is here. So we're going to take the x plus 2 part, make it equal to 0. And we could say that x is equal to -2. Okay, there's our only 0 because since this factor is the same, I could really do this again, but I'll get the same number. So now all we need to do is go figure out what the y value attached to that is. So let's substitute this into equation, let's do number 1. So take x, put it into the first equation, and again, that's purely by choice. You could use number 2 as well, and it'll give you the same thing. So we'll say y equals, x is -2, that's squared, plus 6 times -2 plus 9. So y equals 4 minus 12 plus 9. That means that y is equal to 1. Okay, so therefore, our solution here is -2 comma 1, and it's the only solution. There isn't another one. Okay, since there was only one x, I only get one intersection point. Now we could try this one on our calculator as well before we do that last word problem. So graph those 2x squared plus 6x plus 9. Second equation, 1 minus 2x minus x squared. Graph. Hopefully it's on there. Should be. Yeah. So I can see both. So I see the point is somewhere in here. So we'll go second trace. Option 5 is intersection. Bring that cursor pretty close to it. Enter, enter, enter. It's thinking, and there you go. Sometimes you get this weird decimal. It's very, 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 very small. Basically negligible, so you can just round. So -2, 1 would be our answer, just like we said it would be algebraically. Okay, and like I said, I'm going to skip this one as well. So I'll give you those solutions. So one of them could be 12, comma, where's my y? Well, 1232. Or it could be 15 and 25 over 2. So there's your 2 points. See if you can find them if you try that one out. And we'll do the word problem underneath. So here we're not actually given the system. We have to set it up as well. So we have to write the equation. So it says two numbers are related in this way. 2 times the first number, subtract 5, is equal to the second number. And the sum of the second number and the square of the first number is 115. Okay, those are the 2 pieces of information we have. Create a system to represent this, solve the system to find the numbers. If there are 2 numbers and we don't really know what they are, the question of a system's problem will basically tell you what it is your variable should be. So we're going to let x be the first number and let y be the second number. You can use any letters and variables you want, but x and y are the most common. So if we do it that way, here's our 2 there are 2 equations. We just got to take the words, turn it into an expression. So the first one says 2 times the first number. So we'll start there. First number is x, so 2 times the first number. Subtract 5, so minus 5, equals the second number. Second number is y. There's our first equation that's done. So second equation then, the sum of the second number is y, square of the first number, so x squared, is 115. Okay, and there you go. There's our 2 equations. So now we've just got to figure out a method to solve here. We could do elimination, could do substitution. Either one gets you to the same point in the end. Let's do elimination because the first one is already equal to y. So I'm just going to rewrite it on the other side. So y equals 2x minus 5. Actually, I don't like it there. I'll put it down below. We'll change colors here. So I'm going to rewrite the first one. y equals 2x minus 5. Second one should become y equals negative x squared plus 115. Now, when we go to do elimination here, just remember there's no x squared term in the top. So it might help to actually include 0x squareds, just as a placeholder. So 0x squared plus 2x minus 5. And then the second equation will include a placeholder for the x term as well, because there isn't a term with just x in it. So negative x squared plus 0x's plus 115. Okay, now when we do elimination, we are going to subtract it once again because the y's have the same sign, they're both positive. So we're going to subtract those equations. So 0 equals 0 minus negative x squared is x squared. 2 minus 0 is 2, so 2x's. Negative 5 minus 115, that's negative 120. Okay, so now everything's together, it's equal to 0, it's quadratic, I could factor it. So 0 equals, I don't have to do decomposition here because the coefficient of my squared term is 1. So I've got to figure out two numbers that multiply to negative 120, add to 12. So those two numbers are going to be 10 and 2. The signs matter. So I know it's going to be 10 and 12. I want them to add together to give me that positive 2. So my 12 needs to be my positive because when I multiply, I need a negative. So my 10 is going to be the one with the negative attached to it. So my factors are x plus 12 and x minus 10, which means my two values for x could either be negative 12 or x could be 10. Okay, so we found basically the two choices for the first number. X could either be negative 12 or 10. Now we've got to go back in and find out what the y's are going to be attached to those x's. So you can pick any equation you want. I personally think number 1 is going to be easier. So let's do just that. If we let y equal to 2x minus 5, we're going to say that y equals 2 times negative 12 minus 5. So y could be equal to negative 29. And the other one, let's do 2x is 10, and it's minus 5. So y could be 15. Okay, so therefore, your 2 points are going to be negative 12, negative 29, and it's 10, 15. Okay, so there's your 2 points. There's your solutions. And you can check that on your calculator as well using the same method we looked at before. But essentially, that's the end. That's systems of equations using the same methods you already learned in Math 10. So again, if you do need help, please reach out to somebody, your teacher, myself. You have my email, all that information. We'll see you in the next video.